Hey, welcome back to the course. So in the previous lecture, what we did was we just explored about the MCU block diagram in the case of STM32F4 series of microcontroller, as well as we also explored the block diagram or high-level block diagram of TI's TIVA series of microcontroller. And as I said, if you have any other microcontroller from different vendors, then you just go and check in your datasheet or reference manual to understand the block diagram. Because I cannot cover all the microcontroller which is there in the market, right? I can only point you to the generic concept so which you can leverage to understand your microcontroller. And as I compared these two block diagrams, they are almost same, but there are some minor differences, but the architecture is almost same. Great. So now in this lecture, what we'll do is we'll just discuss some question and answers. So these are some of the thought-provoking questions on whatever we learned so far. And the reference for this question is STM32F446RE microcontroller. Great. So now let's go to the question one by one. The first question, is it true that system bus is not connected to flash memory? So take 5 seconds to think this answer. The answer is true, isn't it? So if you check in the section embedded flash memory interface in the reference manual, you see this diagram. So here you can see that flash is actually connected to I code and decode. So you can see that this line S bus is not going to flash memory. So that proves that in this microcontroller, the flash is actually connected to the Cortex core over I code and decode, and the system bus is not connected to flash memory. That's true. Now the second question. Processor can fetch instructions from SRAM over I code bus interface. True or false? So what is your answer for this? So for a time being, I will say this answer as false, but that is actually not true. There are some advanced techniques by which you can make your processor to fetch instructions from SRAM over the I code bus. That's possible. That we'll see later. So let's not worry about that. But for a time being, I will say false. System bus can operate at the speed up to 180 megahertz. So the answer for this is here, 180 megahertz. That's true. The Cortex processor can run up to speed of 180 megahertz. Great. So that means the system bus can also run up to the speed of 180 megahertz. That's true. Great. So now SRAMs are connected to system bus. True or false? That's correct, right? The SRAMs, they are actually connected to the system bus over this bus matrix. Don't worry, I will explain the bus matrix later in the next lecture. So now next question. A PB1 bus can operate at the speed up to 180 megahertz. So what's your answer for this? Can a PB1 bus operate at the speed of 180 megahertz? That's not true, I think, because a PB1 bus, as they mentioned here, it can only run up to 45 megahertz. So that means, so this is false. Let's say I have a peripheral whose datasheet says that its operating frequency or speed must be above 95 megahertz. can I connect that peripheral via a PB2 bus? So here there is a device, okay, or a peripheral which must run at 95 megahertz to behave properly. Then can you connect that peripheral to processor via a PB2 bus? So what is the maximum frequency of APB2 bus? Maximum operating frequency of APB2? It is 90 megahertz, right? So then it's not possible. You cannot connect it. Now, next question. Processor can fetch instructions as well as data simultaneously from SRAM. True or false? So just think about this answer. Can processor fetch instructions and data simultaneously? No, right? It's not possible. This is false, right? Because there is only one bus which connects to SRAM. So it has to first read the instructions, then it has to read the data, right? Simultaneously, it cannot read it, right? So that's not possible. So processor can fetch instructions as well as data simultaneously from flash. True or false? So what's your answer? This is true, right? It can fetch simultaneously because it has separate bus called I code and decode. See, right? All right. So now next question. What is the maximum HClock? Okay, so now this is repeated. So what is the maximum HClock value of your MCU? So in this case, I'm considering this MCU. So what is the maximum HClock value? All right, so remember that HClock is a notation or abbreviation used to describe the clock frequency or operating clock frequency of the HP bus. So if you go back to our diagram here, so this is the AHB bus, that is PB1 bus, which has the capacity to run maximum speed up to 180 megahertz, and we have also PB2 bus, which also has the capacity to run at maximum at 180 megahertz. Okay, you can even lower the frequency, so that's possible. And the current operating frequency of the HB bus is denoted by the term HClock. So now the answer for this question is 180 megahertz. Now the next question, what is the maximum P1 clock value of your MCU? The P1 clock is actually the abbreviation used to denote the clock frequency, the operating clock frequency of the PB1 bus. Its operating frequency is actually denoted by P1 clock. So P1 clock, maximum P1 clock is 45 megahertz, right? And the P2 clock means the operating clock frequency of the PB2 bus. So that is the maximum value you can use for P2 clock is 90 megahertz, right? Great. So now next question, GPIOs and processor communicate over HB1 bus. True or false? So where is your GPIO? This is your GPIO. And where is your processor? This is your processor. So they both communicate over HB1 bus. That's true because it is connected to HB1 bus, and further from here to here the connection is actually through system bus. So finally this HB1 bus goes and connects to S bus. And please remember that finally everybody should go and connect to system bus through the bus matrix. So bus matrix is your traffic controller kind of guy who actually decides which bus to connect for a given point in time. That means bus matrix will actually serialize the access. So the answer for this question is GPIO connects to ARM processor over HB1 bus via the system bus to the processor. So USB OTG and processor communicate over HB2 bus. True or false? That's true, because here is a USB OTG peripheral that is actually connected to HB2 bus, and finally it is connected to a bus matrix. Then it will talk to the Cortex processor over system bus. Great, that's true, right? Now, next question. USB OTG and GPIOs can communicate to processor concurrently or simultaneously. Is it true or false? Very interesting question. So my answer would be false, because it has to be serialized, right? So this guy and this guy finally, even though they have connected to different HB buses, so the moment they want to talk to system bus, the bus matrix will serialize the access. It's not possible to communicate simultaneously. It's not possible. Processor can talk to flash memory and SRAM simultaneously. So what's your answer for this? The processor, here is a processor, can talk to the flash and the SRAM simultaneously. That's true, right? Because there are dedicated buses, right? The processor can talk to flash over I-code and decode, and at the same time it can talk to the SRAM or system bus. So what's the problem? It can do that, right? So now that leads to our next discussion, that is HB bus matrix. So that actually serializes communication between the controller and the various peripherals on different buses. Great. So now I hope you understood, and if you have any questions, then please raise your questions, and I will see you in the next lecture.